Hello students, today is 18th of April 2020 and in the previous video we had actually started notches and waves and we had actually derived the equation of Q or the rate of flow equation of a rectangular notch, right, in the previous class or in the previous video. So this is the rectangular notch. Please note this particular diagram, rectangular notch and rectangular wave, and this is the cross section diagram that we need to write. Section diagram is very important, and defining all the terminologies and the very simple approach, we got actually Q is equal to 2 by 3 CD into L root of 2G h to the power of 3 by 2. You need to remember this equation. Okay. Now if you see the numericals on rectangular notch, let us go for the first problem. We have to find the discharge of water flowing through a rectangular notch of 2 meter length when the constant head over the notch is 300 mm. See, let us again see the terminologies very clearly. See, this is the head over the notch, okay, your capital H value. So when I want to find out, or when I come to this Q equation and see which are the variables involved here, you have head over notch, you have the length of the rectangular notch, and you should know CD value. So there are three variables. G is known to you, all the other things are constant. So what is given in this particular problem? You need to find Q value. So I want to know what is the CD value. CD value is given to you. I have to know the length of the rectangular notch. I know the length of the rectangular notch, which is 2 meters. I want to know this capital H value that is given. The head over the notch is 300 m. So convert it into meters, SI unit. Just substituting in the given equation, you will get the discharge value, which is equal to 0.582 meter cube per second. It is mere substitution, nothing else. Let us go to the next problem, 8.2. If we need to determine the height of the rectangular wave of length 6 meter to be built across a rectangular channel. There is a rectangular channel, so you want to build a rectangular wave, and the wave length is given to you, which is 6. What is the height of that particular wave? The maximum depth of the water on the upstream side of the wave is 1.8. Okay, on the upstream side. Okay, let it be. Next, and the discharge that is going to happen is 2000 liters per second. Fine. You need to take the CD value as 0.6. Neglect end contraction, so that is left out, so no need to consider it. Okay, don't worry about that. So to find the height of the rectangular wave, okay, now what will be the height of the rectangular wave? See, if you see the wave diagram, okay, this is your wave, this is the channel of the water, okay, that is coming, that is nap. Now this is your H, right, the head of the water above the toppest point of your wave. See the depth, this is the total depth from the bottom of the wave to the top of part of the water. This is your H, the head of the water. H1 minus H will give you H2. Okay. So this H2 is the height of the wave. Now I have to calculate H1 and I have to calculate H2. H to find out H2. Right? That is what is required. So what is given to you in the problem? H1 is given to you, right? See the maximum depth of the water on the upstream side of the river. See, this is the upstream side of the river. The maximum depth of the water. See, this here totally water will be there. Okay, you will find water here. So from the bottom of the wave till the top part, this H1 value is given to you, 1.8 meters. Length is given to you. Q is given to you. Convert it into meters. So divide by 1000. So 2 meters per second. CD value is given to you. So go to the Q equation, 2 by 3 CDL root of 2G h to the power of 3 by 2. Substitute everything. What is the unknown quantity? The H, capital H is the unknown quantity. You will be able to find it out. So do the simple mathematics. Your H value will be equal to 0.328 meters. Fine. Now you find H2. So H1 minus H will be your H2. So H2 is nothing but the height of your rectangular wave. Okay. So 1.8 minus 0.328, 1.472 meters is the answer. Let us get into the next question. 8.3. The head of the water over the rectangular notch is 900 mm. The discharge is 300 meter per second. Find the length of the notch when CD is given to you. So H is given, convert it into meter. Q is given, put it in meter cube per second. CD value is given. L you need to find. Go for the Q equation. Substitute everything. The only unknown quantity is your L. So you can find L, which is 0.192 meters. Fine. So this is the end of the video on the problems on rectangular notches. Okay. I will make up a video on the triangular notch. We will see that. Fine. Thank you.